Hi, 7th grade. Welcome to lesson 4.2, generate equivalent expressions. By the end of the lesson, I want you to be able to say, I can write equivalent expressions for given expressions. Explore it. A shipment of eggs contains some cartons with a dozen eggs and some cartons with a half dozen eggs. How can you represent the total number of eggs in the shipment using diagrams or images? Explain your diagram. So I want you to draw something out, maybe some dots, some squares, and we will use some participation. Pause the video, press play when you're done. Okay, hopefully we got some good creative ideas. I'm thinking if we had a dozen eggs, we would have 12 dots. That would look like one shipment of eggs with a dozen eggs, and a half dozen eggs would look like that. We don't know how many would come in each shipment, but we could multiply whatever we had in the dozen or the half dozen and add them together, and that would tell us the total number of eggs. So how can you represent the total number of eggs in the shipment using expressions? What variables do you use? What do they represent? Well, we know in the dozen eggs, there's 12 eggs. And if we multiply that by D, saying, okay, how many cartons of dozen eggs do we have? Plus, we get 6 eggs and the half dozen eggs. So we're going to say D equals the number of cartons with a dozen eggs. And H equals number of cartons with half. How do the representations compare? How are they different? Well, the 12 dots turned into the number 12. So the 12 dots is now the number 12. And the 6 dots is the number 6. They're different because the first one the picture didn't really have the variable. So picture didn't have variable. All right, example number 1. The student council has spent $300 on the supplies needed to sponsor a dance concert fundraiser. 3 council members wrote the following expressions to represent the total amount raised for tea tickets sold. Can they all be correct? Explain. Step 1, verify that one of the expressions represents the amount raised for tea tickets sold. So 6T is the amount made selling tickets. That makes sense because each ticket is $6. And then subtracting 300, the cost of supplies. That makes sense because you had to pay for it. Step 2, use properties of operations to write equivalent expressions. So they took this 6 parentheses T minus 50, and whenever you see parentheses with a number on the outside, you want to distribute the number to everything inside the parentheses. Distribute means to multiply, so 6 times T is 6T. 6 times 50 is 300. So again, we get 6T minus 300. So that works. Next one, negative 300 plus 6T. Well, we can use the commutative property. Remember, commutative change order, CO. We can flip-flop those and put the 6T in front and the negative 300 in back as long as they both keep their sign. So that one works as well. They are all equivalent expressions. They mean the same thing. So try it. Nancy wrote the expression 3x minus 12 to represent the relationship in a table of values. Use the properties of operations to write 2 equivalent expressions. Well, the first one, they pulled a 3 out. And what I mean by pulled a 3 out is they mean they divided by 3. Because they saw that 3 and 12 are both multiples of 3. So if we divide by 3, we divide by 3. 3 divided by 3 cancels out, and we're just left with x. 12 divided by 3 equals 4. So that ends up working out, and we can check our work by distributing. 3 times x is 3x. 3 times 4 is 12, so minus 12, and that's what we started with. So that's the distributive. Now we're going to show with the commutative. Remember, commutative means change orders. So instead of the 3x being in the front, now the negative 12 is going to be in front. Remember, we can change the order as long as we keep the sign. What property can you use to write an equivalent expression for negative 5, x minus 2? Explain. Well, we can use the distributive and multiply the 5. Or we can use the commutative and we can put the negative 2 in front of the parentheses. So keep the negative 5 out front, put negative 2 plus x, and then distribute. You could do both. Example 2, write equivalent expressions by combining like terms. Write equivalent expressions by combining like terms. Okay, so like terms means they have the same variable or that they're both constants. So I'm looking at A, I have negative 5x plus 2y plus 3x. I see I have a negative 5x and a positive 3x. I'm going to put those next to each other using the commutative property. I can change the order as long as I keep the same signs in front. So we just switch the positive 3x and the positive 2y. Then we can combine those. Negative 5x plus 3x is negative 2x, and the 2y just gets brought down. Next, 1/3 x plus 1/6 x plus y. We recognize that we have 1/3 x and 1/6 x. So we put those two together. We want to add those first. Can't add those unless we have common denominators. So if we multiply this first fraction by 2 over 2, it's going to give me 2/6 x plus 1/6 x, which equals 3/6 x. Again, the y just gets brought down because there's no other y's to combine it to. You can also reduce this 3/6 x plus y to be 1/2 x plus y. That would also be an equivalent expression. Try it. Use properties of operations to write two expressions that are equivalent. Okay, so first we can use the commutative property and change the order. So I'm just going to change the order around and maybe write it as 3/4 n plus 1/3 z plus 8. I can't combine anything here because we've got an n, a z, and a constant, so none of those are like terms. But I could also use commutative property again. Write this down, commutative. Can use commutative property again and start with 8 and add 3/4 n plus 1/3 z. All right, example 3. Identify equivalent expressions. Which of the following expressions below are equivalent to negative 2/3 x minus 2? So first thing we've got here, negative 2/3 x plus negative 2. Well, whenever we have plus negative 2, that's the same thing as subtracting. So this is equivalent. Nice. The next one, negative or positive 2 minus 2/3 x. We want to run into an issue here. We can use the commutative property and change the order. And yeah, negative 2/3 x matches with negative 2/3 x. But the problem is this is a positive 2 and this is a negative 2. So this expression is not equivalent. Last but not least, we're going to combine like terms here. We've got a negative x and a 1/3 x. We add those together, you get negative 2/3 x, because negative x is really like saying negative 3 over 3x. And then we have plus a negative 2, which is the same thing as subtracting 2. So this one is equivalent. Try it. Write two expressions that are equivalent to negative 5/4 x minus 3/4. First thing we can do, commutative property. We can change the order and write this as negative 3/4 minus 5/4 x. Or we could break it up and we could write this as like negative x minus 1/4 x minus 3/4, because then whoever was solving this would have to simplify by combining like terms. We can check our work. If we combine this with this, well, that's negative 4/4 x minus 1/4. 4/4 minus negative 4/4 minus 1/4 is negative 5/4 x, and we just bring along a negative 3/4. So that checks out. All right, 7th grade, let's go see it. Oops. I can write equivalent expressions for given expressions. Have a great day.